So what I'm going to do is I'm quickly talk about some of the tools that you saw and how they are working, and the tools that we are working on to incorporate into RIMORPHIS. And then I will also, at the end, give you a list of some of the ideas we have. And I would like to get your feedback, or we would like to get your feedback on that. So we have divided our tools into three categories. So the first one will be bathymetry tools, and you saw some of that in Yusuf's demo. So how do you process bathymetry data in both space and time and visualize bathymetry data? We are also working on developing tools that uses satellite image. So the idea is how can we find inundation extent based on a hydrologic variable, in this case flow. How can we use satellite images to quantify changes in river planform? And finally, we are also working on tools to visualize and use sonar data, such as ADCP datasets. So I'll start with our bathymetry tools. So just to give you an idea of why and what we are doing, what you see on the slide is map of Indiana, where I'm located. And the lines that you see here are FEMA studies. So FEMA has a lot of cross sections that they have collected for their flood mapping study. And if you look at this map, you see that, oh, looks like entire Indiana is covered with cross section. But if you zoom in, you will see that there are lots of gaps. So the idea here is, how can we use what FEMA has or whatever somebody else has collected, and then fill these gaps with our tools and create an integrated data sets of bathymetry that cover a large area. So the idea is to augment or process existing data to estimate bathymetry at any location. You saw this tool that Yusuf presented. So if you have data, in this case point data, and you are interested in creating cross-section and mesh, the concept behind those tools is shown here. So what we are basically doing is creating histograms of those points. And wherever you have high points in that histogram, we are locating cross sections. So this is a smarter way of locating those cross sections, but we also have options where you can specify at what spacing you want those cross sections. And as I mentioned on the slide here, we have already implemented this tool in RIMORPHIS that you just saw from Yusuf's demo. The other tool that we are working on is, as I said, now let's say you are in an area where you don't have any bathymetry, but there are bathymetry data sets within that region that are available at other locations. So we are developing a deep learning model. So the deep learning model, we are going to train it by using some river channel features related to planform, slope, and maybe even some watershed characteristics. We are going to train that model to create cross sections where you don't have any data. And what you see on the right are some preliminary results, and you will see that the results are pretty good. So the orange line that you see here is the profile that is created by the deep learning model, and the blue line is the actual cross section. So this is one way of creating or estimating bathymetry where we don't have any bathymetry. So this is one of the tools that we are working on, and hopefully we will implement this soon into RIMORPHIS. So using a deep learning model is one approach. The other approach may be using a conceptual model. So what you see again here is a watershed, and the circle area is the area where the bathymetry was collected. So what we are doing, or what our tool does, is it uses this survey data and fix a functional form. So on the right, you see the bathymetry points, and the black shape that you see here is the functional surface that we are fitting to those points. And once you calibrate the parameters of that functional surface to those cross sections, then we can use that functional surface to create cross sections where we don't have any survey data. So this is an example of how this might look. So the profile that you see here on the bottom, the orange, this is the measured data. So if you have measured data, we will incorporate that into this blue cross section. So many times when we use LiDAR or any DEM, it does not have bathymetry. So where you have bathymetry, we should be able to incorporate that like you see here with the orange points. And at locations where you don't have bathymetry, we will use that calibrated functional surface to create what you see here in the black dashed line. So the idea, as I said, is we should be able to use multiple tools and whatever data we have collected to create bathymetry at any location over a large area. And if we are able to do that with continuous bathymetry provided by RIMORPHIS tools, we should be able to create accurate flood models and flood inundation maps. So what you see here is the Wabash River Basin in Indiana. And Wabash Basin covers 80% of Indiana. So we are working on creating a flood model for Wabash Basin, where we are going to have bathymetry for all reaches in this region by using some of the tools. So this is one of the use case that we included in the proposal. So these are some of the bathymetry tools that we are working on. The tools that I showed you, we can think of those are analyzing bathymetry in space. But since we are going to be collecting and storing and accessing bathymetry data from different resources that are collected at different times, we should also be able to analyze river bathymetry or cross-section over time. So what you see here is looking at river profiles and how the river profile has changed over time. So in this case, we are looking at a scenario of how river profile has changed in 50 years. So the idea here is, again, we can use data that is available, process it in both space and time. So this is a tool that we have planned. We have not started working on this yet. And again, when we go into our second hour, we would like to get your thoughts on these tools, whether we should work on this or if you have something else that we should be working on. So moving on from bathymetry tools, we are also working on some tools that use satellite data. So what you see here is one of the tools. So efficiently finding satellite imagery for hydrologic period of interest can be a challenging task. Many times we have to figure this out manually by searching through hundreds or thousands of satellite images. So to automate this process, we are creating a tool, and this tool uses a time series of hydrologic parameter, in this case flow or river discharge. And by using that river discharge, we want to identify inundated areas that are related to the time series of discharge or any other variable, temperature, concentration of any water quality parameter, and so on. So this tool works by first filtering hydrologic data by a threshold or range. So in this case, we might be interested in determining maximum extent of inundation area from large flood exceeding. So let's say if you are interested in finding inundation area that exceed this red dashed line that you see on the top red, the tool should be able to find out the imagery associated with that range. So these images are processed using NDWI or MNDWI to create a water mask of water extent. And these images and products are then linked back to instantaneous discharge to get a concurrent discharge value. So we can go from flow to discharge or flow to map. And if we have map, we should also be able to go back from the inundation area to flow. So this is a tool that we are working on to integrate into RIMORPHIS. Another tool, since we are processing satellite data, if we are going to identify all those rivers and their extent, if we do this over time, we should also be able to estimate or quantify how the river is migrating. So what you see on the left is an input data from Landsat, and by using our tool, we should be able to delineate the river, and by using a series of Landsat images over time, we should be able to see how that river is migrating. And again, the goal here is to both study morphology, but if you are also interested in inundation, so if you have an inundation map that is old, that is going to change as the river is going to change. So we are working on a tool to quantify river migration by using these data sets. So we started with bathymetry, we went on to satellite images. Now again, we are going to come back to a very small scale where we want to use sonar data. So we have ADCP, well, when I say we are going to have tools on RIMORPHIS that can interact with ADCP data, either collected by a federal agency or some private partner. And we should be able to use that data and visualize it. So what you see here is one can assemble all the information available at a reach and create a 3D visualization. So what you see here is visualization of morphology data. So in this case, it is MBES multi-beam echo sounder data, and that is in combination with the information that we are getting from ADCP for doing detailed analysis. This is a cross-sectional view of ADCP data. So I'm assuming that some of you are using ADCP data, and many times, for example, USGS collects ADCP data and they just use one value from that. So what we would like to do is we would like to use that raw data and have tools that people can visualize and use it for other analysis, not just extracting average velocity or average water depth and so on. And here is a close-up view of what I showed in the first slide. So what you have here is detailed bathymetry from the multi-beam echo sounder. We have ADCP and UC vectors. So by using these kind of data sets over time, we can look at how the bed is changing. We can use that for quantifying sediment load and things like that. And this is again something that is planned, and we are right now working with our partner to access to some of these data sets and bring them into RIMORPHIS and start using or start developing these tools. So again, as you see on the bottom of the slide, this is something that is planned. And these are some of the things that we would like your feedback on as we finish talking from our side. Again, this is just another view of one can actually use this in combination with sediment related data and map sediment, suspended sediment concentration, as you see here on these plots. So as I said in the beginning, how can we bring all this sonar data set at one location and you start looking at the overall picture of how the river is changing, not just the bed form, but sediment, other hydrodynamic variables, and so on. So this is something that we are planning to do. Here is a list of some of the other tools that we have thought of including, but as I mentioned in the beginning, this is a pilot or prototype project, so we are not going to do everything. So you will have access to this slide as we go into our second hour. So we would like to get your feedback on what are some of these tools that you find useful. If you think some of these tools are not going to be useful, or if you have ideas on tools that will be used or that are going to be very useful for the broader community, we would like to hear about those. And I think that is it. And